For this optimization question, you're given a bunch of information that is already annotated on the diagram. Apart from the volume is important, we'll come back to that. We have to show that the total surface area is given by a of x equals this function. So for the surface area, we're going to look at it by looking at all the faces. So we've got the front and back, those surfaces. So I'll write front and back like this. You've got the two sides. So I'll just write two sides. You also have the top and the bottom minus the whole. So I'll write top and bottom minus this whole. Now the whole is a square. The end of the tunnel is a square. So that's x by x. So I'm going to minus x squared twice because there's a hole here and a hole in the bottom. So minus 2x squared. But remember, we also have to add the inside of the hole, that surface area, like this bit here, this bit here, the inside of the hole. So that is x by h. h is the height. That would be the same height for the hole as is for the box there. So there's 4 surface areas inside the hole. So I'm adding on 4xh. So remember, area is length times breadth. That's where I got x times h and 4 lots of that. So let's tidy up all of this. So the surface area for the front and back. So looking at the front, we have 3x along here as well. It tells you the top of the box is a square as well. So that information is important. Top of the box, front and back. Front would be 3x along here by x down here. So 2 lots of 3xh. Your sides are also 3x by h, this side and this side. So another 2 lots of 3xh. The top and the bottom is 3x by 3x. So 2 lots of 3x times 3x. Then I had to subtract the holes and add the surface area inside. So keep going, simplify all of this and tidy it up. 6xh plus 6xh plus 2 lots of 9x squared minus 2x squared plus another 4xh. So keep going, surface area, 6xh plus 6xh is 12xh plus 18x squared minus 2x squared plus 4xh gives us 16x squared plus 16xh. Now look at your answer. X squared looks good. We don't have any h's. So this is the part where you need to change your h using the information in the question about the volume. So you know that the volume of a cuboid is L times B times H. You know that the volume of this cuboid is 2000. The length is 3x. The breadth is 3x. And the height is h. Three times 3 is 9, so you've got 9x squared h. Then h would be equal to 2000 over 9x squared. Now, we actually don't have the hole in the middle, that volume can be taken out. So we can take out x by h. So let me go back up to here. Take off x squared h. So I'm just going to add this in quickly. So h is equal to 2000 over 8x squared. Right, so I want to substitute in this h in place of the h for our surface area. So I can prove that my surface area is equal to this. So let's just make sure that all works. 16x squared stays the same. 16x, my h becomes 2000 over 8x squared. 16 divided by 8 is 2. The x on the denominator is going to cancel with this x on the numerator. So I have 2 times by 2000 over x, giving me 4000 over x as requested or required. Now, if you were really struggling with part A, you would come back to that since it's only 3 marks, and definitely attempt part B, even if you cannot do part A, because you're more likely to get these 6 marks by just following the same 5 steps. This one's a 6-mark question because you've to find the minimum value of A. So it's not just the dimensions, it's the actual area as well that I want you to find. So I'm going to just take the question 16x squared plus 4000 over x. So your first step is to put this into differentiable form. All you have to do is move the x up to the numerator, and that will get you your first mark. Now, since you're about to differentiate to find some stationary points for your nature table to prove it's a minimum turning point, write out this sentence so you don't forget. For SPs, a dash of x equals 0. This is also so you don't forget that once you've differentiated, you have to set it to 0 to solve it for the x value of the stationary point. So a dash of x would be 32x minus 4000 x to the negative 2. And that is equal to 0. Now put this back onto the denominator. Over here. 32x minus 4000 over x squared equals x. Multiply every term by the denominator so we can solve this equation. 32x cubed minus 4,000 bring the 4,000 over to the right hand side. Divide by 32. That gives you 8. Oops. Work out the cubed root of 8. Sorry. That doesn't give you 8. It gives you 125. Work out the cubed root of 125. That gives you 5. So you have your stationary point x value. So you have to prove that we have a minimum. So you're at the stage now where you need a nature table. So you need your 5 in the middle. You know that that has a horizontal slope because the gradient is 0. You need to substitute in a number less than 5, a number more than 5. Now you're substituting into a dash of x. So just make sure you don't sub into a of x. You want to sub into the derivative. So you could sub in here, a dash of x, this one or this one. When you substitute a number less than 5, you're going to get a negative answer. It's going to slope downwards. When you substitute in a number more than 5, you're going to get a positive answer, a positive value. That will prove that you have a minimum turning point when x equals 5. But the question wanted us to find the minimum value of a. So I'm now going to come back to the question, a of x, and I'm going to sub in a of 5 to find the minimum value. So 16 times 5 squared plus 4,000 divided by 5. Type that into your calculator or work it out slowly. That gives you 1,200. I don't think we have any units in the question. Oh, centimetres. So squared centimetres would be the final answer there. And that will give you all 5 marks plus the extra one at the end for the area to make 6 marks.